Hi folks, welcome back to Physics with Captain Rod. I'm making this video out here to help you on a couple of your homework problems. So let's see, it says this light bulb right here has a 10 ohm resistance, the battery and EMF of 13 volts. Just a reminder now, so the EMF stands for electromotive force. That's the open circuit voltage of our battery here. Current measurements show 1.05 amps with the switch closed. So what you want to do is we want to start this with a circuit diagram. And the battery itself can be modeled as having an internal resistance and the EMF. So the two symbols that I have drawn here, right, this one right here is going to be for the internal resistance of the battery, and this is for the EMF. Now, I think we don't really know the internal resistance of the battery. Start the rest of the picture. Now, the light bulb has a certain resistance, so we will put a resistor symbol in for the bulb. And there's what our picture looks like. And again, this is representing the battery source right here. Now, with the picture that I have drawn, your current is going to go this way, because we always assume high current, assuming positive charge carriers. Now, what you want to do now is just write yourself a loop equation, or you can find the let me go back here. Let's see. So we have a 10 ohm resistance bulb and unknown resistance R. So write a loop equation. The sum of all the potential differences equals 0. You should be able to find that resistance from that. Then draw a new picture, replacing the 10 ohm resistor with a 5 ohm resistor, and then basically doing the same thing, holding the internal resistance of the battery constant. Let's talk about number 9. Let's see, calculate the power of each bulb shown. So our circuit diagram, and I don't want to do this one for you. We're going to let you do this one. You're going to have a voltage symbol here. Now this one says to ignore the internal resistance of the battery, so you're just going to have the 13 volts. Then you'll have a resistor symbol for this, this, and this. 3 different resistors. Put in the current. Then you can either find the equivalent resistance of the system. Should be pretty easy with the 3 bulbs in series. Or you can write a short loop equation to find the current. Now once you have the current, right, when you calculate power, there's several ways to do it. Current times voltage is one way to calculate the power. I squared times R. Once you know the current, you can take the current squared times resistance to get the power at any given bulb. This is a single loop problem, so keep that in mind. You know, there's only one current. And although maybe I didn't specify it, I had intended here to be switch closed. So I don't want you just saying, oh, the power is 0, the switch is open. Not what I'm intending there for the homework. Now let's take a look at number 10 here. Let's see, 3 identical bulbs shown for each circuit. List them in order of increasing brightness when the switch is closed. So I probably would start this with color coding the potential here. So the red potential is meant to be the highest potential in the problem. And then color code the equipotentials. I think that'd be a good thing to do. And draw the circuit diagram and ask yourself where you think the currents will be highest or lowest. Now, because these are identical bulbs, what I mean by that is to assume the resistance is the same for each bulb. And power is I squared R. If all the R's are the same, it's about the current. So just ask yourself which bulbs will have the highest current, those will have the highest power. So well, that's it. I hope that this video helps you out with those first 3 problems. Have a great day.